Okay, so Wayne, next speaker is Wayne Drevets, who I think many of you know. Thank you, Wayne. I don't know whether you can hear us, but
yes, I hear you well, Andy.
And Wayne's vice president, disease area team leader of neuroscience at Janssen. He's founding president and scientific director of the Laureate Institute, or at least used to be. Are you still doing that, Wayne?
No, yeah,
no. That's a past.
I gave that up when I went to Janssen.
This was given to me by Hugh Martson, so I was because anyway, we have Wayne on here because Wayne is at J&J and is struggling, like many of us, to identify specific outcome variables in the context of use for outcome variables for regulatory approval of drugs of interest. And obviously, given the impact of inflammation on the brain and its interaction with circuits related to anhedonia, as well as neurotransmitter systems like dopamine, which are related to anhedonia, we are very much interested in anhedonia as a outcome variable. And Wayne is too, for other reasons, as part of some of their drug development efforts. And so Wayne's going to talk a little bit about, what are the regulatory issues that need to be dealt with? What kind of progress have they made? I think Wayne is going to be a little bit circumspect about his comments, given, I gather, some proprietary issues with J&J, but we're very pleased to have you, Wayne, and we really appreciate you doing this for us. So you can take it away. We've got your slides up, so if you're ready to go, you're ready to go.
Great. Thank you, Andy. Can you hear me all right?
Yes.
Yeah, we can hear you fine.
Great, and thank you for that kind introduction. As Andy mentioned, I'm going to talk about the use of anhedonia as outcome measures, and I'll talk in particular about some of the development programs in which we're using anhedonia outcome measures that are motivating our quest to try to gain approval from regulatory authorities for some of these, at least one of these scales. Can you see my slide advance? So I'm now on.
Yes.
Okay, great.
Hang on, you've gone backwards.
Okay, so do you see now anhedonia as outcome measure regulatory issues?
Now we do.
You're fine. Go ahead.
Yeah, excellent. Yeah, so the assessment of anhedonia as an outcome measure has held increasing interest in clinical trials research. One reason for this is that in contrast to DSM-defined syndromes, such as major depressive disorder, which comprise diverse symptoms that implicate a plethora of biological systems, anhedonia is thought to more specifically reflect altered output of a well-characterized neural circuitry that subserves reward, learning, sensitivity, and experience. Preclinical research has associated anhedonic behavior with a plethora of biological mechanisms that disrupt the function of these circuits. Clinical research characterizes anhedonia as a transdiagnostic construct that can arise in multiple psychiatric and medical disorders that putatively are associated with pathological mechanisms that disrupt the function of the reward processing circuits. Notably, clinical research finds that despite the resolution of other depressive symptoms during treatment with conventional antidepressants, anhedonia commonly persists as a residual symptom during the treatment of depression. Conversely, you can also see that in depressed patients with chronic inflammation, some anti-inflammatory treatments can improve anhedonia to a greater extent than they improve other depressive symptoms on conventional rating scales. Finally, emerging evidence regarding the molecular mechanisms that regulate the neural circuits.
Wayne, can we just pause you there because we've lost the slides a moment. Our IT guys are going to try and sort at this end. If you could just hang on a tick, or carry on talking, assuming we cannot see the slides.
Okay, we'll do. All right, that sounds great. So I think the last point I'd said was that in that we are now at a point where we're beginning to have, based upon the emerging science that guided our understanding of the circuits of reward processing in anhedonia. We now have some treatments that are being developed that specifically target anhedonia. But
Wait,
yes.
could we ask you if you could try resharing your screen, please? We think that might be
Yes, we'll do. Yeah, we'll do. Do you see that?
No change yet. Change is coming. We're now back on the slide titled Anhedonia as outcome measure, and you're now in full presentation mode.
Okay, excellent, great. And then if I end up if I end up advancing these, can you see the slides advance? Yeah, it looks like it.
Yep.
Okay, great. Okay, excellent. Now, although we've had strong advances in basic and clinical research regarding anhedonia, the regulatory and commercial aspects of that are needed to gain approval and then acceptance of new treatments for anhedonia are really still at the starting line. And some of the reasons for this is that our commercial research indicates that although the term anhedonia is widely understood in psychiatric research, it's not universally recognized by clinicians, patients, or health authorities. And the concept and definition of anhedonia differs among clinicians and across different regions. In addition, you don't have enough sort of real-world evidence and clinical research yet that really have demonstrated the impact on patients of anhedonia in the same way that it has been, the impact has been demonstrated for major depressive disorder. And it's anhedonia per se that needs to have that kind of track record of publications and real-world evidence, also showing how it impacts not just the quality of life, but also employability and other sorts of metrics that are critical for health authorities and payers. And then finally, although we have several different rating scales that we use in research and are considered validated within the psychometric literature for research purposes, in contrast, health authorities haven't found any of these either clinical outcome assessments or patient-reported outcome assessments sufficiently valid in terms of conceptual validity, construct validity, context generalizability, fitness for purpose to endorse them as outcome measures yet. We're working with FDA and other health authorities to try to gain approval at least for a couple of these. One being the DARS, the Dimensional Anhedonia Rating Scale, and the other being the SHAPS, the Snaith-Hamilton Pleasure Scale. But we don't have endorsement yet for these. Some of the interesting challenges that you have when you go to health authorities for these are that they want something to be fit for purpose. And so on one hand, there's no willingness yet to just gain an indication for anhedonia as a transdiagnostic construct. So far we've been guided that you need to focus on anhedonia within specific DSM-defined disorders like major depressive disorder. On the other hand, they want a fitness for purpose. So taking scales like SHAPS or DARS that were not necessarily intended to be just measure anhedonia in the context of one disorder. It still needs validation that they're also fit for purpose for a specific disorder like major depressive disorder. And then finally, one of the challenges is that although we in research, we look for statistical significance of changes in anhedonia outcomes as our indicator that we have a finding. In contrast, a clinically meaningful change is what health authorities and payers want to see established. They want to know if you see 3 points change on a SHAPS that's significant, what is the meaningfulness of that amount of change? And so that has been a challenge to try to establish clinically meaningful change metrics to a level that will be acceptable to health authorities. Now, some of the examples of treatments that, or of the kind of research that is looked for, which in some cases exists in the literature, but so far there's not enough of these studies. We always cite these studies when we go to health authorities, but we need more of them from academics and from other types of research to be able to bolster these cases. But this is an example of showing the clinical impact of anhedonia, and it's from a study in which the relationship between 9 different symptom dimensions were tested as predictors of antidepressant treatment outcome in the large cohort of the GenDep study. And then the finding was replicated in the data from the STAR-D study. And what was found was basically that the interest activity symptom dimension, which of both the MADRS that was used in GenDep and the HAM-D that was used in STAR-D, which reflects low interest, reduced activity, indecisiveness, and lack of enjoyment at baseline, strongly predicted outcome in GenDep, irrespective of overall depression severity, antidepressant type, or outcome measure used. And then the prediction of poor treatment outcome by the interest activity dimension was robustly replicated in STAR-D, independently of a comprehensive list of baseline covariates. Are you still seeing my screen?
Yep, we can see the
okay, great, super. As another example, this is from a study that looked at residual symptoms or syndromes that end up significantly impacting quality of life. And one of the remarkable things about anhedonia is that while you have 77%, or about 3/4 of patients in the acute phase complaining that anhedonia symptoms are profoundly impacting their quality of life. Interestingly, in half of the people who are considered to be in remission using conventional measures, half people in remission still have anhedonia as a residual symptom complex, and it continues to impact their quality of life. One of the programs that we're pursuing anhedonia endpoints on is the aticaprant program, which is a kappa opioid receptor. The opioid system has important connections with the mesocortical limbic dopaminergic system, and will regulate the release of dopamine in several important ways. The kappa receptor in specific, which is activated by dynorphin, the opioid peptide dynorphin, is when it's activated, will actually shut off the ventral tegmental area neuron firing, keeping them from going to burst firing patterns during reward learning and processing. And so it's thought that through that mechanism, kappa receptor stimulation is giving rise to anhedonic symptoms. The dynorphin release is increased by chronic stress, chronic HPA axis activation, the acute withdrawal from substances, and also some types of inflammatory challenge, including inflammatory pain. So all of these will contribute to dynorphin release, kappa activation, and it's thought that these are at least part of the reason why you're getting anhedonia and dysphoria. And aticaprant as a kappa receptor antagonist shows evidence that it can improve anhedonia, especially in those patients who are starting out not only with major depressive symptoms, but also with prominent anhedonia symptoms. This was an example of a proof of mechanism study that was sponsored by National Institute of Mental Health, called, it was known as FAST-FAIL. It looked at patients with mood or anxiety disorders who also had anhedonia based upon a minimum threshold for their SHAPS level. And then very much in the RDoC line of thinking, they looked for proof of mechanism in established efficacy at 3 levels: at the level of neural circuits, of behavior, and of self-reported symptoms. So for neural circuits, they showed that during the monitoring incentive delay task, aticaprant treatment ended up enhancing the ventral striatal response to anticipated reward so suggesting that it moving it in the process direction of normative function. In the center of the slide, you see Diego Pizzagali's probabilistic reward test outcome from the same study, in which Diego showed that aticaprant ended up both increasing the learning rate which was abnormal at baseline, but also gave a more sustained preference toward the more frequently rewarded stimulus. And then finally, they used SHAPS to measure the symptoms of anhedonia and showed a significant improvement with SHAPS. With aticaprant, we conducted a randomized controlled trial to assess the efficacy and safety of a kappa receptor antagonist treatment as an adjunctive treatment for major depressive disorder. And so we selected patients who had been receiving an SSRI or SNRI antidepressant, but were having an inadequate response to that treatment. As a secondary, so our primary endpoint was the change from baseline in the MADRS, a conventional depression rating scale. And as a secondary objective, we used we measured changes in the SHAPS pleasure scale, the Snaith-Hamilton pleasure scale, or SHAPS. But we also tested the ability to use SHAPS scores as a stratification factor to identify the patients with prominent anhedonia. And that was a pre-planned secondary analysis. The primary analysis showed that aticaprant did improve symptoms on the MADRS, in addition to changes on anhedonia-related items of the MADRS, it did have showed improvement in several other items as well. And so you had a greater reduction in depression severity versus adjunctive placebo at 6 weeks. But the more prominent improvement was actually in the patients who had the higher SHAPS ratings at baseline. And so for this stratification, which was decided on before the database log, we just used the midpoint of the anhedonia range on the SHAPS, which is 38. So that the range goes from 20 to 56, and so the midpoint of that is 38. Now, coincidentally, it turned out that was also the median of our SHAPS scores, baseline SHAPS scores in our study sample. The patients who had SHAPS scores above 38 showed a greater improvement, almost 5 points on MADRS change on aticaprant versus adjunctive placebo, whereas individuals in the low anhedonia group showed a much smaller improvement of just a little over 2 points, which is still clinically meaningful. We also in the phase 3 program that we're conducting now, and we anticipate having data available next winter. We are using both the DARS and the SHAPS as outcomes, and then we're also using baseline measures from these scales to try to stratify patients into bands with high and low anhedonia. Another area where we're interested in using anhedonia rating scales is in trying to identify antidepressant effects of immunomodulatory drugs that might especially help patients that are treatment resistant to conventional antidepressants. This slide shows data from 4 different meta-analyses of placebo-controlled effects of various mechanistic classes of immunotherapeutics on comorbid depressive symptoms within the context of primary inflammatory disorders. The depression was measured as just secondary endpoints in these studies, but notably in the one at the bottom right corner by Wittenberg et al. Is from a collaboration that we did with our immunology group at Johnson & Johnson, and then we also collaborated with Ed Bulmore when he was at GlaxoSmithKline. And so it combined the GSK and J&J databases. And we used essentially endpoints for depression that were more strongly biased toward anhedonia. For example, in some of these studies, we had the HADS, Hospital Anxiety and Depression Scale. The HADS was developed by Snaith, who also developed the SHAPS. And so on the HADS, there are 7 depression items. 6 of the 7 are anhedonia items. And so in the studies that were in some of the other meta-analyses where they used HADS, these also were biased toward anhedonia. Based upon the findings that we had, IL-6, an anti-IL-6 monoclonal antibody called sirukumab had the strongest benefit. And so we tested whether sirukumab had antidepressant effects in patients who had major depressive disorder, were on an SSRI or SNRI antidepressant, but had been inadequately responsive to that antidepressant. And to come up with 192 patients at randomization, we ended up having to screen a total of 941 volunteers because we required that patients had both a high sensitivity CRP level greater than 3 at both baseline and screening. And notably, when you took this group who were inadequately responsive to treatment at baseline, 43% of the people we screened did have CRP values over 3. And the average HSCRP of the group of the volunteers that we studied had a CRP of a mean CRP of 4.2. So these were high levels of anhedonia that were evident in patients that are not responsive to antidepressants. Well, the outcome was measured using a Hamilton depression rating scale, and we set the primary endpoint to be 12 weeks. And notably, it was that we did have a significant effect at 8 weeks, but then by 12 weeks, the placebo group had caught up. And it is noteworthy that in industry, we always stop our trials at 8 weeks because a placebo effect tends to catch up in longer trials. But this one we ran 12 weeks because the sirukumab wasn't yet at steady state by 8 weeks, so we decided to run it longer. Nevertheless, we were able to show that sirukumab had a significant reduction in IL-6 levels that you see on average in the right-hand panel. And then we had some post-hoc tests or some secondary analyses that were all meaningful. In one case, we had differences at the higher CRP threshold, which I'll show on the next slide. And then in the other, we found important improvements in anhedonia, which I'll also show. At baseline, we had done a stratification at randomization rather into different CRP bends. So again, the intent to treat sample had a CRP over 3 at both screening and baseline. And then we also stratified for patients who had had CRPs over 8, and then those who had CRPs between 5 and 8. And the reason we did that is highlighted in the upper right-hand corner. This is a graph from the publication by Andy Miller and Charles Rasson, where they used infliximab in a similar clinical sample. And what they found was, even though there wasn't a significant change in the overall Hamilton Depression Rating Scale score relative to the placebo group, there was a significant correlation between CRP and the improvement in the Hamilton Depression Rating Scale scores, in which you actually had a better response to in the placebo group than the infliximab group for people with low CRP scores, shown on the right side of the graph. Whereas you had an improvement in the patients who, shown on the left side of the graph, where they had CRPs above a cut point that they found in their graph of 5 points, 5 milligrams per liter on the HSCRP. And our biomarker team just took these data and then modeled out where on this graph would you need to have an average of at least 2.2 HAM-D points change versus placebo in order to get the minimum clinically important difference on the HAM-D. And they estimated that it would be 8 milligram per liter. And so that was one reason we had looked at this. And sure enough, in the group that had 8 milligram per liter HSCRP levels at baseline, they did show a strong antidepressant effect on the Hamilton Depression Rating Scale. It's also noteworthy that when you look in the lower right-hand corner, that's also the group that had the biggest drop in IL-6 levels. The group with CRP of greater than 8 is in the far right of the graph. Probably the most important finding we had, though, was if you took the full intention to treat sample, there was a significant improvement in the SHAPS. And interestingly, that became significant. Usually the SHAPS takes longer to have meaningful change in clinical trials. And so it did need 12 weeks in this case in order to show a significant benefit. And then following the cessation of the double-blind period, we did follow people out to 22 weeks. And the improvement in SHAPS in the sirukumab group relative to the placebo group remained significant, which may reflect the relatively longer half-life of the anti-IL-6 antibodies. And then we also looked at that subgroup with CRPs over 8 at screening. And here you see that they had a larger improvement in the SHAPS scores than did the entire sample, but it was significant in both. So some of the things that we learned from this study were that one, Anhedonia may be more sensitive to drugs with anti-inflammatory action than a conventional depression rating scale like Hamilton. And a similar finding was identified in the Toronto group in a study using infliximab in bipolar depression, published there by Lee et al. And this is also compatible with the data from Andy Miller and his team at Emory in the series of studies that they did where they looked at various mechanisms like dopamine turnover rates in non-human primates and other kinds of mechanisms to show that inflammation could impair function within the reward processing circuitry, and these studies are reviewed in the 2 reviews articles that are identified here. Now, sirukumab its development was stopped due to safety concerns that happened in a rheumatoid arthritis study. So for our next sort of attempt at developing a treatment that was acting on primary immune mechanisms that could potentially benefit these patients, we are testing a P2X7 receptor antagonist. And we're testing it in bipolar depressed patients. And this is a study that we'll read out this summer. P2X7 is an interesting receptor because it's stimulated by ATP that as it's released either by physiological stress that can include from cellular damage, but also ATP increased by psychosocial stress is enough to activate P2X7. And this then promotes assembly of the NLRP3 inflammasome and enhances processing release of inflammatory element beta. And this was a target of interest initially because genetic studies showed gain in function polymorphisms would not only increase the release of IL-1 beta, but they also would increase risk for major depressive disorder and bipolar disorder, and they would increase the depression severity in the index episode for both bipolar depression and unipolar depression. More recently, both protein-wide association studies and transcriptomic studies also implicated this receptor. Here are some of the examples where you had evidence of increased IL-1 beta in bipolar disorder shown on the left, in CSF on the upper left-hand corner, and then in plasma in the lower left-hand corner. But on the right is a study where from a collaboration that we had called NEMA that included several UK universities to look at biomarkers in depression. And these are transcriptomics data run in Carmine Periente's laboratory, who was one of the collaborators in this consortium. And what Carmine's group found was that both P2X7 and IL-1 beta messenger RNA are in fact elevated in this case in major depressive disorder patients. And the green bar, or I guess we could call it blue-green, the third group from the left is a group who had current depression and had been non-responsive to their current antidepressant treatment. And then the group on the far right had current depression and were not on treatment. And both of these groups showed elevated IL-1 beta and P2X7 relative to either the control group, which is the pink bar on the farthest left, or to patients in that olive green bar that had were currently receiving antidepressants, and they were responsive to them, so they were currently in remission. So treatment responders, or treatment remitters actually, did not continue to show IL-1 beta or P2X7 elevate, or did not show evidence of the messenger RNA elevation, but the people who were continuing to be depressed did. And then to try to look at anhedonia, what we did preclinically was just studies in rodent models, and these were done by Anindya Bhattacharya from when he was at Johnson & Johnson. And what he found was that brain penetrant P2X7 antagonists, but not non-brain penetrant P2X7 antagonists, had the ability to reverse anhedonic symptoms as measured by sucrose intake in animals that had been subjected to repeated stress. And so we're in our study in bipolar depression, we are measuring anhedonia as an outcome measure in addition to conventional depressive scales. And lastly, we're seeking regulatory approval now for anhedonia endpoints. It's as I mentioned in the beginning of slide, there are still many hurdles to jump over in terms of preparing the marketplace and the clinic for looking at anhedonia as an endpoint. So market access, reimbursement, physician preference, patient preference, all needs a lot more education from all of us in order to pave that path. Yeah, I'll stop there.
Many thanks, Wayne. What we're going to do is I'm going to just take 2 minutes to present a couple of slides that Karine, who should be doing my job at the moment, would have tried to weave into the discussion, and then we'll go to a discussion section. We get Anne-Lee and yourself to deal with the questions both here in the room and online. So if you bear with me, just, I hope, no more than 2 minutes. Karine Brouillon, unfortunately, can't be here. She is board member at Boehringer, responsible for the human pharma activities from phase 2 and beyond. So she has a very wide range of responsibilities, not just mental health, but she really wanted to show her support for the need to do more in mental health by coming along. But so, unfortunately, business circumstances have made that too difficult. So I will be talking tomorrow, but my side of the argument, I'm actually the CNS research lead, so I come from the other side of the company. So very quickly, that's not me. What we did want to do, and very simply, we've just heard from Wayne, who's heavily involved in getting the S-ketamine over the final line. But what we wanted to acknowledge as an industry, as well as academe, it's taken us an awfully long time to do anything new. And I'll go through this in a little bit more detail tomorrow. But hopefully the sorts of discussions we're having today will enable us to facilitate a new golden age of psychotherapeutics. But these last two slides are the ones that I wanted to represent on behalf of Karine. And I think we've got this message coming out already, but it really does require us to have a partnership and a collaborative ecosystem. We need to bring together understanding of the patients. We need to understand the strengths and weaknesses in the healthcare professional area. Psychiatry and mental health is unusual, that there are actually a wide range of types of healthcare professional involved in delivering this sort of treatment. It's not just psychiatrists, it's clinical psychologists, it's mental health nurses, it's all sorts of people. It's a very, very complex space. Clearly, we've got the scientists and researchers, we've got industry academic experts, policymakers. That, we don't just mean FDA and EMA, but that also means how do you structure a health service in whatever country you live or work in? How do you actually make sure that mental health actually is something that governments are listening and talking about? Because unless we get some of that discussion going, then maybe we can't shift the dial in various different places. Health authorities, again, they have to work out the socioeconomic aspects, but the health authorities are very different in different countries and different domains. So again, that's something else we have to do. And I'm getting a lot of feedback. 2 times, okay. Everything I say is twice as important because of the echoes. I'll keep going. And then finally, on the right, we've got the payers and the insurers. And again, understanding the different ways that different countries and organizations do that is something that may be very important. Now, this slide, though, are the sort of messages that Karine was going to try and weave in, which within Boehringer, we feel are things that we would like to see and help support. So in a sense, you can think of this a little bit as a statement of intent. But finding some way that we can develop a European mental health strategy would make an awful lot of sense, in our opinion. And support and we've already supported the dedicated European Year of Mental Health. We'd like to see that there is industry supporting EU member states to ensure that the national mental health strategies integrate mental health across all the policy areas that they have influence over. Further, the EU member states could collect, report core mental health indicators at regional and national levels. Maybe the digital world is now in such a space that we can actually begin to join up some of these informations and get traction from size and the power that would bring. EU member states could seek to establish mechanisms to encourage implementation of community-based care of mental health. And then the last one, which I think is an interesting one, is the idea that we should ensure that the appropriate pathways to make available effective and regulated prescription digital therapeutics for serious mental health conditions is also another component. And that's something I will touch on again tomorrow. But for instance, we've already seen in the pre-COVID to post-COVID era, an example would be in the UK, I believe that somewhere in the region to 80 to 90% of patient-physician interactions prior to COVID were face-to-face. Now 60% are virtual. So you've gone from 90% face-to-face to 60% virtual in 2.5, 3 years. So the world is changing, and we need to work together as a community to do that. Now, I'm sure Corinne would have woven those in much more subtly and tactfully into the questions and answers, though these come over a little bit black and white, but at least it gives you an idea of what's going through her mind at the moment. So, Andy, shall we get the question and answer session going? Hopefully Wayne is still online.
Yes, and we'll have to be a little bit brief to catch up in terms of time. We're running a little behind. There are some questions online that I'll take, but first, how about people in the audience? Any questions for Ann Lee or for Wayne? Wayne, are you still online there? Can you hear us?
Yes, I am. I am, Andy. Can you hear me?
Yes, we can. Okay, we have a question over here.
So I can shout maybe. So Wayne, what did we learn from the canakinumab? So Wayne, maybe you are aware of the IL-1 receptor beta blockade that was run in cardiovascular diseases and preventing lung cancer incidence. And so I was wondering what we learned from canakinumab product, so blocking IL-1 receptor in depression or mental health related anhedonia. In those patients showing up with cardiovascular disease and or lung cancer. Because there were thousands and thousands of patients.
Yes, no, that was a very compelling study. And so one of the primary things that we learned was that you can't directly block IL-1 beta receptors. You can't stop all of IL-1 beta because of the safety consequences. Yeah, in that study, just so people are aware of what happened. Although they did show improved reductions or prevention, basically, of lung cancer and cardiovascular disease, they had so many deaths from sepsis that there was no net benefit on death rate in the sample. So we learned not that you don't want to go after all of IL-1 beta. The advantage of P2X7, which we thought was a great advantage, was that you can get IL-1 beta production, processing, and release from other from the NLRP3 inflammasome by a variety of other mechanisms. And so with P2X7, you're not blocking all of IL-1 beta release. You're just blocking that portion of it that's mediated through P2X7 activation, which interestingly is again gives you the portion that's activated by psychosocial stress. Now, also we've done a series of clinical studies and in preclinical studies to look at safety of P2X7 receptor antagonism. And one of the things you don't see is increased risks of infection risk. So we do think this is going to be a safe way to modulate immune function, at least in those patients that have activation of P2X7 receptors.
Thank you, Wayne. There's Fred, are you saying something?
Hi, Wayne. So I did my PhD on P2X7. So I have a question.
Oh, great.
Question for you.
Fred, you have a question? Okay, go.
So, I mean, I think that as a purinergic receptor and purinergic specialist is what really merged like all the field between oncology, neurology, and psychiatry. And there was an interesting study done on glioblastoma. And they observed that there were different types of P2X7 receptor that were leading to either re-emission of the tumor or progression, like either re-emission or progression of the tumor itself. And I was wondering whether your group has looked into these different type of isoforms of P2X7.
So we have looked. What we have done is to look at the oncology literature, because you're right, there was some literature suggesting that P2X7 antagonism may have a risk of malignancy in some cases, and so we had involved a variety of consultants in this regard, and they had, in general, the conclusion was that the isoform that we're affecting is not one that we would expect malignancy risk from. And we have been looking for evidence of that in preclinical studies, and so far have not found that. But there, it is noteworthy that there is a literature that supports what you're saying, looking at even other tumors as well.
Thank you, Wayne. I have a question for Ann Lee.
Great.
So you told us about the Olink platform which you're using. Can you, I mean, I'm not very well educated, but I know there are other platforms out there. And can you give us a little idea if we're wanting to get into proteomics and that kind of thing, how do you go about choosing a platform, and why would we want to choose Olink versus some other platforms?
Thank you so much. That's an excellent question. So I won't be shameless here and put a lot of plugs, but clearly there's a variety of tools out there. And I think where the space is at right now is really where this question is. We're at the crux of that question. You know, there are many options. I myself have experience with mass spectrometry and different immune-based platforms from my PhD study times, but things have evolved so much for mass spectrometry, for the immune-based platforms that are out there. There are many companies offering these solutions. I cannot speak to the details of those other solutions that they're existing. Something that we focus on a lot with Olink is to listen closely to the community, and we have a very agile, innovative strategy to make sure that we can offer the content that is required. That said, we have focused lately a lot on expanding the library and just making sure that we can cover as much of the proteome as possible. But we always do that with very strict validation. We have a 15-step validation for each antibody that we include, and you can imagine, since there's 2 antibodies for 5,400 proteins, it's a lot of work. It's about 100 people or 2 years or something like that. So those are the kind of things, the kind of value that we try to focus on to make sure that everything we put out there is validated and that you know very certainly what you're measuring and that's that protein. But you know, I think it's great that we have a lot of players in the field, and I think the next few years we're going to keep seeing new studies come out. There are a lot of head-to-head comparisons in the literature that you can look at, but I think where we're at right now, a lot of people are choosing to complement the technologies and actually incorporate several of them to get as full coverage as possible of the proteome. So, and I think that.
And are these desktop things that you have in your lab, or we're sending samples to?
Oh, you can choose. Yeah. So
Yeah,
you can send them or build it into your own lab or send it to a core facility close to you.
Yeah. Thanks. There's a question right here.
Yeah. So first of all, you have a very interesting platform, and I mean, I really enjoyed your review. I did spot one paper where you were mentioning metabolomic stratification or identification of metabolic panels associated with autism spectrum disorder, and I also saw that it was autism spectrum disorder versus controls. And in psychiatry in general, when you're looking for markers that would be specific to a specific psychiatric disorder, I think it would be interesting to always compare with another psychiatric population to be able to establish specificity, because neuropsychiatric disorders share common markers, or you have clusters that go beyond DSM diagnostic criteria. And it's not just for scientific aesthetics, it's actually a fundamental basis for drug development, because then we encounter challenges with the FDA. So I think it's super important that we always control for other general psychiatric populations.
I really like this comment. I mean, I think that's what we're really wanting to see more of, not only in neuropsychiatric conditions, but just these contrast groups, right? Where you can hone in on what's been very extensively discussed here, which I think is so valuable to move more towards a sort of pathway-based view on the pathophysiology. So I think that looking at these modules, so to speak, within from a molecular perspective, is going to show us the differences, the discrepancies between diagnoses and the similarities, and then those could be druggable because they're like right at the protein level. So I really like that.
Yes, excellent. I'm going to take, just to respect our online viewers, we have one question. We'll take one question, then we'll break for 10 minutes. This is a question to Wayne. The question is, what is your opinion on the relative importance of motivation / wanting and pleasure / liking to anhedonia?
You know, that is a great question, and the fact is that anhedonia is really a symptom cluster more than just a single symptom. And so when, you know, the standard definition we use, like among clinicians, is inability or reduced ability to experience pleasure or find interest in things. But the fact is that you also have a loss of incentive, or when you have diminished reward learning or reward processing, it takes away incentive and diminishes motivated behavior. And so in the experimental literature, this is well recognized, and so there'll be different measures, aspects to the measure of reward of what we would term anhedonic deficits. And as you point out, wanting, liking, and then motivated behavior are each separable aspects in experimental research. And in contrast, that we haven't gotten that far in sort of recognizing that those aspects for regulatory authorities or for commercial groups, and have instead been keeping things more simple. Nevertheless, one of the things that attracts us to the DARS is the DARS does try to, it has 4 different dimensions that it measures, that one of which tries to get at that motivation aspect, as opposed to the interest in the pleasure aspects. And so the DARS does pick those up, and there was some evidence from the FastMess trial. They used both the SHAP, but they also used the TEPS. And the TEPS pleasure scale showed, as I recalled, it was the consumatory pleasure scale within the TEPS did show an improvement with aticaprant. But in contrast, the anticipatory subscale of the TEPS did not show improvement with aticaprant. And so we have thought that the DARS, because of it looking at 4 different dimensions, might end up being more suited for a mechanism like aticaprant. And so are studying that as our key secondary outcome instead of SHAPS.
Great, thank you, Wayne. And the DARS is, what's that abbreviated? What's the full name of that scale?
It's the Dimensional Anhedonia Rating Scale.
Okay,
Dimensional
great.
Anhedonia Rating Scale. Yes, the Toronto group has been the real sort of originators with that, but they did try to get some feedback from regulatory authorities and to ensure that it would have the construct validity that would be looked for by regulators.
Great. Thank you so much to both of our speakers. Let's give them a little round of applause. And then